Hey guys, so this is a step-by-step tricky trig example for a definite integral that uses substitution. So I'm going to walk through kind of all the steps at a more drawn out pace. This was actually a request, which I do take requests. And just by the way, if you find my content helpful, if you could consider liking my videos or subscribing to my channel or leaving me a comment, with any kind of feedback, either you like this or, you'd like to see more of this or maybe even a criticism, that really helps me out and supports my channel. So I really appreciate when you guys kind of interact with me like that. And that's kind of the only thing I ask for in return if you find these videos helpful. Okay, so let's jump into it. Here's the example. So this is definitely going to be tricky. So you can pause the video if you want to read it over. So I've got this integral from 0 to the cube root of pi squared, and then this is the square root of x sine squared x to the 3/2 dx. Okay, so just by looking at this, you can tell you're going to have to use substitution because there's just no formula for this, right? And so your sense, if you've been doing substitution long enough, is that probably something to do with this and this relationship here. That's kind of probably a good guess for where we're going to start with our substitution. So I'm going to set my u equal to x to the 3/2, and then my du, so I just take the derivative of that. So the derivative would be 3/2 x to the 1/2 dx. Okay, so this is the first thing you have to be careful of when you're kind of looking this over. So when I look at my du and I compare it to kind of what's in the problem, so if I just want to check off kind of what I was able to actually sub out here, so this x to the 1/2 is taken care of here. Here's where my dx is. But this 3/2 here, that is nowhere in this problem. So when that happens, you want to manipulate this part here so that basically so that what this looks like is exactly what you're going to substitute in. So what I want to do here is I want to multiply both sides. I'll just kind of note it here. I want to multiply this side by 2/3 and this side by 2/3. So I'm just going to multiply by the reciprocal. So this will give me 2/3 du equals x to the 1/2 dx. And so now if I look at this, this is exactly what I'm left with in the problem, right? So here's my u right here that I'm going to make a substitution on. And then kind of everything else in the problem, this and this, now we're going to properly sub it out. Okay, now this is a definite integral, and I personally think it's a lot easier to just change your limits of integration right now. So let's go ahead and do that. So the idea behind this is, I think this is pretty logical. Like, it's got a nice flow to it. That's why I like changing them. So the way I think about this is, if x equals 0, then what does u equal? So to figure that out, you just go back to what was my u. My u was right here. So if I just plug 0 into this, I would get 0 again, right? So there's the first one that I'm going to change, so it actually doesn't change at all. And then if x equals this cube root of pi squared, let's first rewrite this actually with a rational exponent. I think that's going to make our lives easier. So the way to write that as a rational exponent would look like this. So, and not pi, not x. Okay, so there we go. So if x equals this thing right here, just in rational exponent form, then what does u equal? So now I'm going to plug this right in to this equation here. So this part right here. So I'm going to plug in pi to the 2/3, all of that to the 3/2. And now you can see that you can use the product rule, and so actually all the exponents drop out. So this is I think this is kind of clever. So my u just equals pi. Okay, so let me summarize all this information now. What do we actually need? So I'll clear some space. Okay, so there's all my information just summarized so I can make a little more space for myself. So now we can start substituting things. So as I rewrite this, so my limits of integration are going to go from now 0 to pi. Then this square root of x and the dx, that's going to be my du, and then I can just sub my u right here. So this will be sine squared u, and then, so x to the 1/2 and du are going to be equal to 2/3 du. Oops, sorry, this should say dx, not du. Sorry. I think my coffee hasn't quite kicked in yet. Okay, so this is going to be this times 2/3 du. So there's kind of everything substituted. And one thing that I want to do just to make my life a little bit easier, I'm going to take this 2/3 and I'm just going to drag it out in front. So this will be 2/3, so then I go from 0 to pi, sine squared u du. All right, so now here's what I've got to integrate. And now, looking at this, you might think, wait, did we do the substitution right? We can't integrate this. We don't have a nice formula for this. And so this does not mean that we did anything wrong. It just means that this problem is still going to be kind of tricky. So we have another twist to it. So let me clear some space. And now let's figure out how are we actually going to integrate this. So we don't have an antiderivative for sine squared u. And you cannot, sometimes what I see people do are like they get a little desperate and they try to like integrate this, and then they might say like to integrate this, I'll see things like this equals, I don't know, like negative cosine u squared or something. Like this is not a thing, right? That you cannot do this because you're kind of making up like integrals at this point. So this doesn't work. So then you have to think about what do you know about sine squared u. And so now you're really kind of going through the Rolodex of trig identities. And so you might think like, oh, well, sine squared x plus cosine squared x equals 1. So that would mean that sine squared x would equal 1 minus cosine squared x. So this is usually where people start. They think through this one, but notice that we still don't have a nice antiderivative for cosine squared x. You have the same problem. So this one's not going to work. So then the next best choice would be your half angle identities. So here's the relevant one that we need. If that didn't come to you, like I would highly recommend just when this happens, usually you just want to stare at the half angle identities for a moment. And so this is one way that the half angle identity can come up, but I can make a manipulation to this where I square both sides. And if I square both sides, it looks like this. And so this is actually kind of what we're going to use here. So I need to get my integral in this form, this sine squared x over 2 form. I need to make a manipulation, and then I can kind of invoke this. So this is what we're going to do. So the first thing that I've got to do is just manipulate my u right here. So I want to rewrite this as 2/3. So I'll go from 0 to pi sine squared. So I'm going to rewrite this as 2u over 2 du. Why did I do that? Because if you look at this half angle identity, that just helps me kind of think through the detail. So basically what this is saying is whatever is up here, this is then what you're going to plug in right here for this half angle identity. So now instead of having just u, I have 2u, but this is totally fine. I can now use my half angle identity and rewrite this problem like this. So 1 minus cosine of 2u over 2 du. So the half angle identity is super helpful for these types of integrals, and it's probably something that you want to have memorized and kind of in your back pocket. Okay, so now we can push forward with this, so let me make some room. And to finish this, I've got to break this up into pieces. So I'm going to rewrite this as 1/2 minus 1/2 cosine of 2u. Now, notice that when I broke this up, so this is just like one term, right? This is one singular fraction. And now I've broken this up into 2 different terms. So when I do that, I have to put parentheses around this now to stay proper. So you want to be really careful with that. And now I can integrate each part separately. So this is going to become 2/3, and let's see, I'll put a square bracket here. Actually, I'll just do a round bracket. Okay, so the antiderivative of 1/2, that will be 1/2 u. And then this part, so I've got the 1/2 times, so if I take the antiderivative of the cosine of 2u, this will be 1/2 sine of 2u. And so then all of this is still going to be from 0 to pi. Okay, so now we've just got to evaluate everything. So I'll clear some space again. And now we just want to be clever with how we're kind of evaluating this. So as I look through this, notice that I could factor out this 1/2, at least one of those 1/2. So I'm going to factor that out in front here. So I get 2/3 times 1/2, and then this u minus 1/2 sine of 2u, and then I have to evaluate this still. And so then I have 1/3 u minus 1/2 sine of 2u. So now I can go ahead and push forward with this. Okay, so this is going to become 1/3. So this will be pi minus 1/2 sine of 2 pi. So there's the first one. And then minus 1/3 0 minus 1/2 sine of 0. Okay, so now we're really in the home stretch here, so I'll make a little room. Okay, so as I evaluate this, so this guy right here, sine of 2 pi is just 0. And then this is also 0. So really all of this is zeros, like this whole thing is 0. So the only thing that's not a 0 is this pi right here. So that's actually going to be it then. I just take 1/3 times pi, and my final answer is pi over 3. So that is the final answer. So kind of a lot of work to get there. You got to be careful as you go through it, but that's it at the end. And so that'll cover it for this example. So if you guys have any feedback for me, feel free to drop it in the comments. And otherwise, I'll talk to you guys in another video, I'm sure.